Hello my dear student. In last lecture we had seen velocity time graph and its cases. Now we will see area under velocity time graph. Area under velocity time graph. Area under velocity time graph. This is our x-axis and this is our y-axis. X-axis represent as time and y-axis represent as velocity. Suppose our velocity is constant, then graph is like this. V1 is our constant velocity and initial velocity is V0. We find area at two time. Suppose this is T1 and this is T2. So we draw a perpendicular. This and this, and we find this area. Before starting this, we know that this type of when graph is constant velocity, then this type of motion is known as uniform motion. This is the straight line which is parallel to time axis, then angle is equal to 0 degree. Because constant velocity is parallel to time axis, so angle is equal to 0 degree and slope is equal to tan theta. Tan theta is equal to perpendicular by base. Perpendicular is equal to velocity, base is equal to time, is known as acceleration. And when theta is equal to 0 degree, then tan 0 is equal to 0. So tan 0 degree is equal to 0. So acceleration is equal to 0 degree and velocity is equal to constant. When this type of graph is known as uniform motion graph. When acceleration is 0 and velocity is constant, then uniform motion. So figure velocity time graph for uniform motion. Uniform motion when velocity is constant and acceleration is 0, then this type of motion is known as uniform motion. Now we will find area. We will find this area. Area is equal to इंटीग्रेशन ऑफ T1 से T2 के बीच में फाइंड करना है T2. Here velocity is constant v and time changes T1 to T2, so dt can be written as. Now we will written like this: velocity is equal to rate of change of displacement into dt. V is equal to ds by dt. This will be put in here. This will be put in here. Then this become d से dt कट जाएगा, then बच जाएगा T1 से T2 and ds. And ds is known as displacement. Here we find displacement. When we will find area under velocity time graph, then we find displacement. Hence we can say that area under velocity time graph gives the displacement repeat again. Area under velocity time graph. Here velocity is constant, then slope is equal to 0 degree, slope is equal to tan theta is equal to perpendicular base perpendicular is velocity, time is known as acceleration, velocity by time is known as acceleration, and theta is equal to 0 degree, then tan 0 is equal to 0 degree is equal to 0. So acceleration is 0 and velocity is our constant, v1 is our constant. So this type of motion is uniform motion. Area, our velocity is constant v and time changes t1 से t2 के बीच में dt. This can be written as velocity is known as rate of change of displacement. So we put value ds by dt कट जाएगा, then displacement बच जाएगा. This is our displacement. Hence the area under velocity time graph gives the displacement. Now we will find area. Area is equal to area of rectangle, area of rectangle. This is rectangular in nature. This perpendicular and this perpendicular. So this is the rectangular in nature, and opposite side are parallel. So this type of figure is known as rectangle. So area of rectangle. So we can written as area is equal to displacement. So we can written area is equal to displacement, and displacement can be written as area of rectangle. Area of rectangle is equal to here this length v1 minus v0, into width चौड़ाई this t2 minus t1. This is our width, only this width, and this is the length. Width is equal to t2 minus t1. This is our displacement we find. Now we will discuss second cases. If graph is like this axis time, x-axis represent as time and y-axis represent as velocity, and our graph is this like a straight line. Then we find area t1 and t2. Suppose this is our t1 and this is our t2. So we draw a perpendicular and this draw perpendicular. This is not a rectangular, so we can divide it into two parts, a straight line and parallel to time axis. This perpendicular, and this perpendicular, and this perpendicular. So this is the rectangle and this is our triangle. We find this area, we find this area. Figure velocity time graph for uniform motion. So area is equal to displacement. When we find area of velocity time graph, then give displacement. This is the important point. When we find area of velocity time graph, then give displacement. So displacement can be written as area of, suppose this is our A and this is our B and this is our C and this is our D and this is our E. So area of A, B, C, D, E. A, B, C, D, E. So displacement this area, and this area can be written like this. This is our rectangle. So rectangle can be written as length into width. Length, this is our A. Width, this is our A. AB into this BC. This and this are equal, and this length are equal. This is our rectangle plus area of triangle 1/2 base A and D can be written as AD into height, perpendicular distance, DE, height. This is our triangle, this is our rectangle. This is our area of rectangle, and plus this is our area of triangle. If our graph is like a sinusoidal, this is sinusoidal in nature, then we find area. X-axis represent time and y-axis represent as velocity. This type of, then we find displacement. Velocity time graph give the area is displacement. Velocity time graph of area is give displacement. So we can written as displacement is equal to area. Displacement is equal to area of A plus A2 plus B3. So we can written as area is equal to, this is above part is equal to A1 and this is our negative part, so A2 plus A3. This is our displacement. Note area above the time axis is positive and area below time axis is negative. This area above time axis, this is time axis above, this above here is taken as positive, and below the time axis, this is our time axis and this is below the time axis taken as negative. So area is equal to above time axis A1 positive and below time axis A2 we can take as negative, and above time axis A3 can be taken as positive. So displacement is area this, but area can be written as above time axis is positive and below time axis is negative. So we can written like this. Now we will discuss area under acceleration time graph. Area under acceleration time graph. Area under acceleration time graph. X-axis represent as time and y-axis represent as acceleration. If our acceleration is constant, then graph is like this. Then we find area of acceleration at time t1 and t2. Perpendicular draw this perpendicular. Suppose this is the t1 and this is our t2, and we find this area. So we can written as area is equal to acceleration is constant, this then can acceleration and time vary, so del t can be written as, and from time t1 से t2 के बीच में हम लोग को निकालना है. So we can written as t1 से t2 के बीच में acceleration is known as rate of change of velocity. So acceleration we can put as dv by dt into dt. This will be put in as here, and d से dt कट जाएगा तो हम लोग को बच जाएगा t1 से t2 के बीच में dv, and this is our velocity. Hence area under acceleration time graph gives the velocity. So area of this figure can be written as, area is equal to velocity and area of rectangle. Area of rectangle. Repeat again. Area under acceleration time graph. Suppose acceleration is constant. Then we find area of t1 and t2 के बीच में. This area will be find. So area is equal to can be written as acceleration this and time varies dt. From t1 से t2 के बीच में निकालना है तो acceleration is equal to rate of change of velocity and dt से dt कट जाएगा, dv बच जाएगा, dv is equal to velocity. So area under velocity time graph gives velocity. This is our important points. Area under acceleration time graph gives the velocity, and area under velocity time graph gives the displacement. So area is equal to written as this is the our rectangular, this perpendicular, and this is are parallel, and these are parallel, opposite side are parallel and all side are perpendicular. Then this type of graph is known as rectangle. So we find area of rectangle. Area of rectangle is equal to length gune breadth. Now we will see equation of motion by graphical method. We know that the motion of an object moving in uniform acceleration can be described with the help of three equations. We know that the motion of an object moving in a uniform acceleration can be described with the help of three equations. First equation is v बराबर u plus at. V is our final velocity and u is our initial velocity, and a is acceleration and t is time. And second equation is s for displacement is equal to ut plus half at square. S for displacement, ut initial velocity, t for time, and a for acceleration. And third equation is 2as is equal to v square minus u square. This is our three equation. We can describe the motion of an object moving in a uniform acceleration. This is our equation. V is our final velocity and u is our initial velocity, and a for acceleration and t for time. In next class we will derive the equation of motion. Thank you for watching my video. We will meet in next class.